Hello everyone, this is Diwan and I'm gonna present a distinction level presentation for the TNE30024 MQTT project. In this demonstration, I'll focus on the distinction level requirements only. Those include securing a Mosquitto MQTT server using a certificate chain and updating the Python MQTT programs to use TLS certificate chain validation as well, using multiple MQTT topics for publishing and subscription, and using a third Python UI client to replace the graphical MQTT client. So first of all, I'm going to show you the certificate installation proof in my Cyberduck. Here under my MQTT folder, you can see all the certificates installed. The important certificates are the root CA, intermediate CA, and the Mosquitto server certificate, and the server chain file as well. This matches the distinction requirement because the broker is not just using one certificate, it uses a full chain with root certificate and with the authority as well. Now, just to verify these certificates, I'm going to open my VS Code and show you that the TLS encryption proof is working properly. Here in my terminal, I have OpenSSL output open, so which already says right here, the broker is reachable on secure MQTT port 8883. The TLS version right here, I can see the TLS handshake has been done and the verification is okay. So this demonstrates that the communication with the MQTT broker is both encrypted and certificate validated. Now, my first client is device1.py. So it simulates temperature and humidity readings. It publishes the sensor readings to device 1 data, and it publishes the status updates to device 1 status. It also subscribes to multiple topics, which is device 1 commands and the public. So device 1 demonstrates both multiple topic publishing and multiple topic subscribing as well. Now I'm going to show you the device 2 for the project, which is device 2.py, and it simulates air quality. As you can see, it simulates air quality and carbon dioxide readings. It is also secured using TLS certificate chain validation. It publishes data to device 2 data and status updates to device 2 status. It subscribes to device 2 commons and device 1 status and public. This shows that both client programs subscribe to multiple topics and the clients publish messages to multiple MQTT topics. Right now, I'm going to show you the UI client and how to input manual commands as well. So this program right here, the UI client Py, this is the third Python program, and it acts as a simple monitoring and control interface. It subscribes to the data and status topics from both device 1 and device 2. It can also generate and publish command messages back to the device. The menu shows commands such as turn on cooling and start ventilation. So for here, I'll try to turn on cooling in device 1, which already done here. Send turn on cooling to device 1, and let's go back to device 1. So here you can see turn on cooling, device 1 action, cooling system turned on. Let's get back to our UI client and then try to press 3, which should turn on the ventilation in device 2. So start ventilation to device 2, you can already see right here, start ventilation to device 2 and go back to device 2. Right here, you can see start ventilation, device 2 action, ventilation system started. Now, I'll show you some code implementation as well. In device Pi, I have the broker is set to my rule host 135, which is here, and the port is set to 8883. So the port is because the secure MQTT over TLS. The clients both use root ca.crt, device 1 and device 2 right here. And also the code also uses the client TLS set as false right here. So which data topic is used for sensor readings, and the status topic is used for the device's current state, and the command topic is used to receive instructions from the UI client. And also the program uses a client publish to listen to MQTT topics, And when device 2 receives start ventilation, it prints the ventilation action as well right here. So and you can see client publish as well. Now going back to UI client Pi, it also has the menu system where where users can select a command as well. Now I'm gonna talk about how this matches with my EN30024 engineering spine integration. This MQTT project can integrate with my previous spine project, which I use for smart parking and EV charging spot finder. The MQTT system could act as the secure communication layer between the physical sensors and the web platform. So, for example, a CD sensor or ESP32 device at an EV charging bay could detect whether a charging spot is occupied or actively charging. That device could publish live occupancy or charging data to the Mosquitto MQTT broker. Then the backend or web application could subscribe to those MQTT topics and update to their user interface in time. And the UI client in this project also shows how commands can send back to devices in a real smart parking or EV charging system. This makes the system more suitable for a real smart city or EV infrastructure environment where secure real-time communication is important. Thank you.